Howdy, hey, what can Miss McDonald teach us today? 4.2 Part 1. Miss McDonald, take it away.
Thank you. Great job. All right, logarithmic functions. Okay, so the rest of the chapter is going to be about logs. We've got 3 more sections. Everything's logs. I know you have done these before, but we are going to put out of our brain what we have learned about them before and any preconceived notions about how we feel personally about logs, okay? And we're going to just pretend we're starting from scratch here and move on from there. All right. So we're going to start with this problem. Find the inverse of y equals 3 to the x power. The inverse of y equals 3 to the x power. We did inverses back in section 2.9. Do you remember the first step to solve for an inverse? Flip the x and y. So the x equals 3 to the y power. And then the second step was always get the y alone. Which that's where we're going to run into an issue here. We want to try to isolate a variable, especially a variable that's in the exponent. We run into a problem where we don't really have the math to be able to do that. So that's why logs were invented. Logs were invented to create the inverse of an exponential function, to allow us to solve for a variable that's in the exponent. The inverse of this, if I take this equation and write another way, is this log statement. Log base 3 of x equals y. These two equations are equivalent to one another. The first one is what we call exponential form. The second one is what we call logarithmic form. They both are the same relationships. The second one, though, gets that variable alone, that y by itself, which is what I want. What you don't want to do if you're trying to solve for an exponent is you don't want to like divide by 3 and both sides. You can't do that. It's not going to get the y by itself. It's not going to pull it out of the exponent. You can't take a root of both sides, things like that. It's still not going to isolate the y, so you have to use a log. So the most important thing you can know about a log, and 90% of the problems that we're going to do, we're going to use this property. It's how to write a log as an exponent and an exponent as a log. So let's say I have an exponential statement that's x equals a to the y power. That's the exponential form. The equivalent logarithmic form is y equals log, we would read that, base a of x. Log base a of x. Because our a base had some restrictions before in the last section as an exponent, those same restrictions are going to apply to our logarithmic bases. Our logarithmic bases must be positive numbers. They cannot be 0, and they cannot be 1. So the first set of problems we're going to do today, we're just going to practice one form, writing it as the other form, and vice versa. Okay. All right. We're going to do the first couple of these together. I'll let you try a few on your own today. All right. We're going to do one logarithmic and one exponential to start. Starting with the top left. 2 to the 10th power equals 1,024. I want to write that, convert it as logarithmic form. So I'm going to start with log. The base of your exponent is always the base of the log. So the base of my exponent is 2. That is also the base of my log. 2, and that's going to be a subnotation when you write it. Remember, the goal of having a log is to get the exponent alone. So when you write in log form, the exponent, in this case 10, should be by itself. And then I've got a little extra space there. That's where that 1,024 is going to go. So that is its equivalent logarithmic form. Now there is a way to remember this. It's a little phrase called bend the bunny. B stands for the base. E stands for the exponent. And n stands at the number that it is equal to. So that's my bend. When I put it in logarithmic form, I end up with the b, then the n, then the e. And that's my bunny. Then the bunny. That's a good way to remember which order things go when you write it. Okay? You convert the other direction very similarly. Let's say I have log base 2 of 64 equals 6. I want to write it as an exponent, as a power. My base of my log is the base of my exponent. What's alone in the log equation is the exponent, and then set it equal to whatever's left, in this case, the 64. And that one's really easy to check. 2 to the 6 equals 64, yes. And we move on. Okay? Try the other 4. These should be very quick problems. Remember, as promised, there's going to be quite a few Math XL questions, but many of them are really short like this. I'm going to get some people up to the board. I'm going to have you guys put up the top one in the middle. Great. Bottom middle. But I signed you one and you've got it. Put it up when you're ready. Your cookies are weird. Okay, let's see. Log base 9 of 1/3 equals -1/2. Log base. Okay, which one's which? Oh, we gotta be careful with this one. I see what you did. See how the equation's flipped from the other ones? The power's on the right, the number's on the left. So if you want to use the bend the bunny rule, you have to put a to the q on this side equals p. Does that make sense? So this should be log base a of p equals q. Your exponent should always be alone in those log equations. I think the other ones are good? Yeah, those look okay. Questions? Converting to logarithmic form or exponential form? Okay, moving on. All right, next problems are evaluating a log. These are again meant to be ones that you are doing without a calculator. Log base 3 of 9 we are evaluating. Evaluate means figure out what it's equal to. So we're trying to figure out it's equal to x. Let's figure out what x is. Because I can write an equation, we can now write with exponents. What would that equation look like with exponents, Gracie? So, yeah, you're one step ahead. 3 to the x equals 9, and then this is why it's meant to be done in your head. You can hopefully figure out 3 to what power gives you 9, and you said squared, so it evaluates to 2. In general, this is what a log is asking for when it's being evaluated. It's the base to what power will give us the other number. So when we look at this next one, log base 9 of 1/3, it means 9 to what power will give us 1/3. Remember, logs help us solve for exponents. We're always looking for the exponent. So you can write it if you want to as an equation. 9 to the x power equals 1/3. 9 to what power would just give you 3? A half, right? Because a half does what? square root. But the 3's in the denominator. It's a reciprocal. So what do I have to put in an exponent to make it flip? A negative. So it evaluates to negative 1/2. The 1/2 would give me a 3. The negative would flip it and make it a 1/3. Make sense? Try the other two on your own. I'll give you a second. The base, what power, gives you the other number. You're solving for the exponent. Okay, left off back here. Which part's the answer? What? That whole thing isn't the answer. What parts of it is the answer?
Oh, okay.
Yeah, that's the answer. That's what I'm looking for. Okay. So 1/2 to what power gives me 32? Well, 2 to the 5th would give you 32. So it's a 1/2, so you need that negative pretty much is the idea. Does that make sense? Anytime you've got a reciprocal value, you're going to have a negative exponent that you're looking for. And remember, even on your test, no part of your test is no calculator. The one part for this chapter is basic calculator, so you could even do a little guess and check if you needed to for those. And then the next one, 7 to what power gives you 1? Well, anything to the 0 power gives you 1. So it actually doesn't matter what that base is for that one. If I had a base of x, log base x of 1, doesn't matter, x to the 0 power give me 1, it would still evaluate to 0. Questions there? Okay. So now, let's try some equations. Log base 2 of x equals 3. Log base 2 of x equals 3. Again, write it with exponents. Write it with exponents, you can probably solve it. What's this going to look like with exponents? So x equals 8. Z. Log base z of 125 equals 3. What does it look like with exponents? Right. And if I have a number in for the exponent, I can get rid of it by using what? I can use a root, or in general, you can just use a reciprocal. A cube root is the same as a 1/3 power. Anytime you want to cancel out an exponent, it's reciprocal will do the trick. So you can just take both sides to the 1/3 power, or mental math. It's helpful to remember that that means cube root. So z equals 5. You guys try the bottom two. Solve the logarithmic equation. Start by writing the exponent. Get done early and you want a challenge problem, I've got an ACT problem I pulled out of a book on the board here on the left. If you want to try it. Should be able to do it now. We've got everything we need. So this one, 3 to the y power equals 127. Again, 3 to the third gives you 27. It's a reciprocal, so you need the negative. This one, if you write with exponents, 3 to the 0 equals that big quadratic, and anything to the 0 power is 1. Quadratic, move the 1 over, and then this guy is factorable. -3, +2, 3 and -2 then are your two solutions. As I promised earlier this year, they will put quadratics anywhere they can. They definitely will show up in this chapter. Okay. How are we doing on the challenge problem on the board? Anybody got it yet? Yeah. Okay. Speaking of which, on your graphing calculator, if you hit math, and then go down to, I think it's A, log base, it says. Log base. That is how you type a log of any base into your calculator. So you could type in log base 4 of 256 and see that it's 4. Okay? Yeah, there is also a log button on your calculator, which we're going to use in a minute. The log button in your calculator on the left side of your keys, that is a log that's a common log base 10. So you only want to use that button if you have a log of base 10. Same thing with the ln. Do you remember what the ln is? E. That's a log base E. So those we use often, so that's why they get their own buttons. But in general, you want to use the log base function. There's also a shortcut for it. It's like alpha and then math. Well, there's one like one of the F functions at the top, like F1 and alpha window. Yeah. If you make it one of those.
You have to go down to 5. That's more buttons.
Alpha window 5, or math alpha math.
Look how close it is.
Or
You can just keep going.
you can just press 5 button. Okay. All right. Do whatever makes you happy. There's 8 ways to get to it now. So, okay. Moving on. All right, what you see up here, these are actually the same set of properties written 3 different times. We're not going to write all this down. I do need you to write them down at least once, though. There are 4 main log properties, this guy, this guy, this guy, and this guy. And that one I'll write a little bigger for you because I know it's little. This is A, log base A of x equals x. Okay, first property says the log base A of A is equal to 1. Log base A of A is equal to 1. That's actually just one of our exponent rules in disguise. If I write this with exponents, it says a to the first power equals a. We all know that to be true. Second property says log base A of 1 equals 0. Again, just an exponent rule in disguise. A to the 0 power equals 1. We know that. Anything to the 0 power gives me 1. The other two talk about that a log base and an exponent of the same base will cancel one another out. We know that to be true because they are inverses of one another. An exponential equation and a logarithmic equation are inverses. So if you have log base A of A to the x power, the log A and the exponent A cancel each other out, base A cancel each other out, and you are left with just x. And then vice versa, if you see something like this, an exponent base A and a log base A, they will cancel and you will just be left with that x, whatever it happens to be. Okay, now what you see written over here, these are actually the same set of properties, but written with a common log, which is a base 10. Common log, just like the button on your calculator, you will not see the 10, ever. Okay, it's kind of like when we have a square root, we never see a little 2 next to it. We all just know that if we see a root, it's a square root because it's the most common root there is. And then everything else we see is the 3 and 4 and 5 next to the other ones. Same thing with logs. Log base 10 is the most common log, so we just don't put the base there and everybody knows, hey, it's a base 10 if there's no number written. The other special one is the natural log. Natural log is a base e, and it can be written two ways. 99.9% of the time, you're going to see ln x. That means natural log of x, but you can rewrite it if you like as log base e of x. And again, those two have their own buttons in the calculator. Okay. All right. So we've got four properties: common log, natural log. All right. These will be quick. Let's say I want you to evaluate log of 1,000. If I see no number in the base, what number is it? 10. So I have log base 10 of 1,000, which means 10 to what power gives me 1,000? Or you're always solving for the exponent when you're evaluating log. So what's the answer? 3. Do you guys know the zeros rule? The power of 10 is how many zeros show up in the number. So if you see like 100,000, there's 5 zeros, so it's 10 to the 5th. Okay, log of 0.01. Again, it's a log base 10. I think these decimal ones are easier if you write it as a fraction. 0.01, if you were to read that number, it would be 1/100th, right? Two decimal places is hundredths. So 1/100 is really that number. 10 to what power gives me 1/100? 2 gives me 100, -2 would give me the reciprocal. Yes. Natural logs, I think these are even easier. Natural log I can see like this, or I can see like this if it helps. This is actually one of the log properties you wrote down. I have a log base e and a power of base e. They cancel. The answer is 4. Natural log of 1/e, or I could write log base e of 1/e. E to what power gives me 1/e? -1. Yep. Natural log of 2 means e to what power gives me 2. Now, e is an irrational number, so you're not going to be doing that in your head. This is where you would use a calculator, and Math Excel would say round to 3 decimal places or whatever. So you would just in your calculator type in ln, the button, to enter. Yes?
0.693.
0.693. Good? Questions? Okay. Easy enough. Last slide of evaluating. Try these 4. We're done. Log base 4 of log base 3 of 81. Just like any problem that you've done since back in the day, when you have a parentheses, something inside, something else, you work from the inside out, right? So I'm going to first figure out what log base 3 of 81 is. That means 3 to what power gives me 81? 4th power. So log base 4, and I can replace the parentheses. That log evaluates to 4. 4 is the exponent. Now I evaluate that. Log base 4 of 4 means 4 to what power gives me 4? 1. Final answer is 1. E to the natural log 5 power. Natural log is what log base? E. So I have E and then a power of log base E. What's going to happen? Cancel. 5. Okay. This one, that little caret, it's an x squared there. So I have natural log of e to the x squared minus 3x power equals 10. I have a natural log, which is a log base e, and a power of base e. They're the same base. So what's going to happen? They're canceled. And I'm just left with the x squared minus 3x. Don't overthink these. I have a quadratic. What do I do next? Subtract 10. And then it factors to what? Minus 5. plus 2, so your solutions are x equals 5, -2. Last one. I have an exponent base 10 and a log with no number, so base 10. So power of base 10 and a log of base 10, what happens? Cancel. And I have 2x plus 3, no longer in the exponent. Equals 11. And that's just a linear equation. 2x equals 8. X equals 4. Logs aren't that hard, are they? They're not. Okay. Tomorrow we're going to do the graphs of logs, and that'll finish up this section. Remember, Friday will be a work day for you guys in here on Math Excel. Okay? I'll do the cell lotto.